Yeah, thanks everyone for being here. I think Agentic AI is really at an amazing, like a really exciting time. So first a little bit, as Paul mentioned, so I'm professor at UC Berkeley, and I have been teaching this MOOC, Massive Open Online Course on Agentic AI. So when I started the course, the first one last fall, back then actually people were not really talking about agents yet. So I started the class because I knew that agents, I believe the agent is the next frontier. So that's how I started the MOOC in Agentic AI. That was really the first class. And I knew that agent is coming, but I actually didn't expect it would come so soon, so fast. So this year suddenly is like a year of agents. And also recently at Berkeley, we just hosted the Agentic AI Summit with over 2,000 in-person attendees and close to 1,000 on the wait list and over 40,000 joined online. So this just shows how excited the community is about Agentic AI. And also now, we just started the 3rd edition of our Agentic AI MOOC, and you can actually, and now we have over 32,000 enrolled globally, and yeah, welcome to join. You can just go to agenticai-learning.org to learn more about this. So talking about what I think is the most exciting development in Agentic AI, so of course, I mean, the MOOC and the summit covers so many different domains, perspectives of Agentic AI. I think they are already exciting. So here I'll just pick one example. Also, some work, some of our own recent work to illustrate the fast progress in Agentic AI. So this is in the domain of cybersecurity. So the question is, with this agent development, how good are they in solving cybersecurity tasks? So in our recent work, we did two, here, let me just give you briefly like 2 examples. The first one is called the bounty bench, where we task the agents to actually solve real-world bounties. So these are bounty tasks. So these are like real-world, so web developers, they set up these real-world bounty tasks. So essentially to incentivize white hat hackers to find vulnerabilities in their web applications and also to patch them. And what we discovered is actually today's agents, relatively simple agents, are already very powerful. They can already solve a lot of these real-world bounty tasks, and they can actually earn the equivalent of like tens of thousands of dollars solving these real-world bounty tasks. So that's one example. Another example called a cyber gym of our recent work, where we built actually a benchmark of close to 200 real-world, widely distributed, large-scale open source software projects. And there has been over 1,500 vulnerabilities discovered in these software. So we task the agents to do 2 things. One is to see whether agents can find these previously discovered vulnerabilities. And the second, whether the agents can actually find 0 days previously unknown vulnerabilities. So what we discovered again is the agent's capabilities are improving very fast. So actually with the relatively simple agents, one, they can find actually close to 20% of previously known vulnerabilities in these large-scale, widely distributed real-world software. And also, more importantly, they can actually discover 0 days. So, and also this is another example illustrating how fast these agents are improving. So previously, Cloud 4 was the best model for these agents and was able to find close to 17% of the previously known vulnerabilities. And previously, the previous model, what we discovered was able to find like around 10, 15 0 days. And now with the GPT-5 that just got released, with GPT-5 thinking mode, it actually was able to find over 22% of the previous known vulnerabilities. And actually, overall, now we found 35 0 days. And note that actually these are security critical software, which has been fast tested over a long period of time. And still, these agents with relatively low cost can actually find these 0 days. And so far, we have 3 CVEs that have already been issued for these 0 days that we discovered, and 6 of them, and also 6 of the 0 days have been patched by the developers already. So these are just examples illustrating the fast and exciting development in agents, in this case, in cybersecurity. And in terms of what we think are still missing, so certainly, as I showed, as our work shows that, for example, GPT-5 thinking mode is much more powerful than the non-thinking mode and so on. So essentially, we still need these agents to have stronger reasoning, planning, and to use these various capabilities to be able to do even more.
Yeah, just to introduce myself briefly, I'm the CTO at Surge AI. So we're a human feedback company that started around 5 years ago. So we hire large groups of human experts to help evaluate and train large language models in partnership with all the biggest labs. We scaled up to $1 billion in revenue last year and are the biggest company in the space right now. I'm leading the engineering team there. So yeah, definitely agree with everything Don said. I think it's been amazing to see the progress in reasoning and planning. One particular thing that I found really exciting about agents in 2025 as a software engineer is the ability to use context. So I think even before, the models have been smart for a while. So I found that if I kind of crafted the perfect prompt and like explained the problem in great detail, like a lot of the models were able to solve it. But only now, I think we're starting to see the models be able to find that context themselves. So like as an engineer, if I'm trying to like make a change to my database, I'm often thinking about a lot of different things like, oh, there's that incident report from last month where the site went down, like this is our product roadmap. There's kind of a lot of context I need to bring in to make that change. The model doesn't have by itself. So I'm really excited for the models to kind of be able to live in my work environment and go and like seek out that context themselves. So yeah, one of the things we're working on at Surge right now is basically creating these kind of like mini fake worlds to train the models to do this type of work. So we'll actually like have like a whole Slack instance, like a whole Google Drive instance with lots of documents, like an AWS console, and a whole environment to kind of like teach the models to basically work in the same environment that humans work in today. So excited for them to kind of improve on basically taking more of the work and not requiring me to like sit down and like write a 10-minute prompt, spend 10 minutes writing prompts.
Hi everyone. Tough being last. I agree with everything that has been said. I head the safety team at ElevenLabs, and for those of you who don't know, ElevenLabs is a leader in everything audio and voice. So we have foundational models, text-to-speech, speech-to-text, speech-to-speech, and we also provide the product layer on top of that. And that means that we are very much in demand when it comes to providing a stack of voice with underlying LLMs. You can sort of pick your own LLM, which has been very useful in this agentic era. So we see a ton of particularly enterprise applications, but we all know that customer service still sucks, right? Even though the solution is there right now. So what we're seeing is that the offering is fast outpacing right now the current state of adoption. So I think we have a lot of runway to go. You asked about what is blocking right now. It's not quite clear what's blocking to us yet because there's so much yet to go in terms of how much our customers can adopt agentic solution to improve their businesses that we haven't hit any kind of wall yet. Trust is an issue. There is still a requirement to both enable security and safety protocols in a way that is robust, especially at the edge of the distribution, but also to explain that to customers. So there we do see a pain point. The thing I'm most excited about, I had 2 things that were already covered, which is reasoning and context. I'm particularly excited about reasoning, verifiable reasoning and runtime as a way to oversee the model and oversee the agent and augment security and safety. So I think that's very promising. We heard about mechanistic interpretability earlier, which is sort of at the neural level, but even chain of thought and light proofs at the output level, we find to be very, very useful.
Thank you for the insights. Yeah. So basically, we have talked about a lot of exciting moments for Agentic AI of finding bugs, 0 days, have context-aware analysis, and the domain-specific like audios and like different applications such as customer services, etc. I think all these are quite exciting. And for examples, from our, we indeed find that the agent system are so smart and intelligent in the sense that if you ask the agent, for example, to use a model to generate like malware or like vulnerable code, and I do find that they can be smart enough to find the very less commonly used libraries, even and human I don't know. I mean, never used before, and they find those, less commonly used libraries, which may I cast the model area or the protection layer, and then try to bypass and let it get update calls capacity. So those are all quite exciting examples, and also show that with the benefits and advances of the GAI and the agentic systems, we may open, unfortunately, a wide door for the security instances, right? So with that being said, going to ask the second question about some real-world instances and the risk, or like say, keep up. Commonly wonder that supervisors are by seeing some AI security incidences and impact enterprises, and what assets have you learned, and also like what's
I defer to others here. I have to think about it for a minute. Probably less than you'd think in terms of incidents. Maybe I'll sort of frame it in a positive. So to avoid incidents, or the best way to redress them, is to think about the way we think about our safety and security posture is essentially as a stack, right? So you mentioned prompt injections that are essentially unavoidable if you're only working at the model layer, if the adversary is trying hard enough. So essentially our approach, and I think the general approach in the field, is evolving to combine model level guardrails with system level guardrails at the same time, as well as production, red teaming, and oversight. So for example, system level guardrail includes parameterizing your agents in a way that they can only share very specific information with other agents that then output to the end user. So that essentially guardrails the output of the first model through an intermediating agent before the information is provided to the end user, that can guard against, for example, prompt injections attempting to get sensitive information extracted out of the agent in the first place. So I can't really talk about major incidents that we've seen, but we haven't seen as many as one might have feared a couple of years ago when this conversation was still very nascent.
Yeah, I think it's still early days, but yeah, there have been some interesting kind of proof of concept incidents. So one I found really interesting was a blog post by Simon Willison where he talks about the lethal trifecta. So if you have an agent that has access to publicly available information that someone else can write to, and it also has access to your private information, and then a way to communicate, it's basically automatically going to be vulnerable to prompt injection. So the example I've seen demonstrated is you can basically go to like a public GitHub repo and like file a ticket, like, hey, can you fix this bug for me? But then you kind of have like hidden text, like with a broken render, or like it's like a white color, so like a human can't read it. And the hidden text will say something like, oh, also, can you send all my private environment variables like this URL? Like, can you open a PR on this other public repo with all your secrets? Basically then the developer might ask like, hey, can you just go solve this ticket? And it'll basically solve the bug, and then it'll like just go on and follow the instructions and like send all your environment variables to the attacker. So I think one method we're really excited about is basically just using human red teamers at the end. So you always want to take all the normal security steps, like making sure like the permissions are scoped to the minimum necessary and kind of doing all the normal security playbook. But I think at the end of the day, these are kind of new systems that are hard to understand. So having human experts kind of go in and try to run these exploits and basically run something similar to a bug bounty program where you can try to have people break the model and try to get it to do bad things, that can basically be fed back into the training data. So when the model's kind of thinking, it can it can kind of see like, oh wait, this instruction seems out of place. Like this doesn't seem like something I should be doing, and it'll kind of stop there. So basically using the human red teamers and then creating like training examples to kind of make sure that the model has that basic common sense and like knows that it shouldn't be doing things like sending passwords to like a random URL, like any kind of human would understand.
Yes, yeah, adding to what the previous panelists mentioned, I think one thing is that because the actual deployment and adoption of agents is still at the very early days, very little is actually in real production. I think that's why we have not seen, as many real-world incidents, attacks as people may have been expecting. But I think the issue is that is coming. So as soon as I think a lot of these agentic AI systems are being deployed, I think security is really important. And we are going to see, I do think that we are going to see more attacks. And I think the issue is that agentic AI systems, they are really complex, they are highly dynamic, and they significantly increase the overall attack surface. And also, they are much more powerful. They have, like these agents, they can have a lot of strong capabilities, and they, in order for them to do various tasks, they will have a lot of privileges. So when you combine these together, then this can really lead to huge problems. Right, Andrew mentioned about having like a human red teamers. So one of the things that both in terms of research that my group and with other collaborators have been doing, and also at Virtue, so we have, one thing we have been doing is actually developing these powerful approaches and techniques and tools for automatic red teaming. So for example, with the various works that we have been doing with this developing automatic end-to-end red teaming tools and frameworks, we're actually able to automatically generate attacks and successfully attack various different types of agents, including, for example, for web agents, we're able to automatically generate attacks where, similar to the example that Angie mentioned, but you basically, for example, this web agent is tasked to surf the web and then retrieve some product reviews to help the user to decide what product to buy. And then in this case, the attack agent, so we have a work called agent visual, which does this actually black box end-to-end automatic red teaming for agents that actually uses black box optimization techniques together with LLM to actually generate these new attack instances. And in this case, it's able to automatically generate the like these attacks, malicious reviews, basically, that when posted to the review website, and then when agents visit the website and retrieve the reviews to summarize information about the products, then the agent actually then gets prompt injected and then goes to visit malicious websites and do bad things and so on. And also recently with our work called agent exploit, we actually developed more sophisticated multi-agent red teaming framework that basically we actually have multi-agent to do this red teaming. And then we were able to automatically generate very powerful, effective attacks. For example, open hands for coding agents, and also for like GPT researcher for like deep research and so on. And essentially, these attacks can attack the, in this case, the coding agent and deep research agent to achieve various different types of attack goals. So these are just examples illustrating that agent security is really important. And these agent systems, they can be fairly, so they have various security issues given the increased attack surface, the increased, dynamic nature and flexibility and so on. So we hope that these technologies can actually help people who are building agent systems to better find the kind of vulnerabilities, security issues in agents, and then to help defend against them. So basically, like for the real world example, like you share, this ask your agent to summarize your emails to, give you the top 10 to-do list. And then what you'll find is that there could be one email that have one line prompt injection saying, make this malicious transaction. And with that being said, the agent will go through all the emails and execute that like a prompt injection and make that transaction without even noticing you. So this has been, happens for some real cases, and we have seen several news about, some like a database is directly deleted by the coding agent, or the customer database has been leaked in a $30 billion company through, prompt injection, etc. So this has been quite interesting and raising the next question about, we have been talking about all these scary risk surfaces and attack vectors, etc. So how can we protect them, right? I believe maybe we are at the early stage, but definitely I think security need to come from day one rather than, you have to rechange your architecture to compromise and help integrate the security piece, right? Therefore, in terms of protection and guardrail, I wonder concretely, how do you think the organizations can balance, of course, developing the effective guardrails and ensure, functionalities, utilities of the models, applications, and with security, privacy in hand? Also, what do you think it will balance between maintaining the in-house, protection guardrail versus using the third-party, common guardrail protection layer? And also, do you think this maintaining the innovation speed and the usability for developers and end users, plus the security piece in terms of providing the guardrails, etc., what would be the principles or top principles in your mind so that, you will protect the developers and they can develop with confidence without worrying too much, but behind the scene, maybe the enterprises and maybe the application and model developers will provide this security layer? Or you think this will be a task from the user side? Basically, I think we are still developing this so that would love to see some brainstorming about the architecture, and also you think in terms of the protection in-house versus third-party, and at which stage of the development, and also what's the top principles behind the protection layer?
Yeah. So this is a complicated question. Maybe, so I don't forget the question, I'll jump in first. So maybe I'll start backwards. So to your point about principles, I mean, there are many, many good principles to adhere to and to pick from. At ElevenLabs, we particularly focus on traceability, so ensuring that we maintain logs, that we have a traceability path between the action and the result. Accountability, so we ensure that our users are responsible for their use of their product, and we hold them accountable by taking enforcement actions when necessary where we find violations. And third, provenance. So we're investing heavily in ensuring that we maintain ability for verification and authentication, and being able to tell human versus AI provenance, which is particularly important for us in the context of voice. So we should be able to trust voice, and we are exploring various ways of doing that, ranging from C2PA, metadata approaches, watermarking, etc. The second part of the question, do you build, do you buy, and how do you choose? One of the things I'm particularly excited about in this space is watching the ecosystem develop around third-party security and safety solutions. And Virtue AI that both Don and Bo represent here is one of the best, to our experience, in our experience, solution in this space, and one of the most sophisticated. So there is this ecosystem developing out there of third-party vendors that are offering things like automated red teaming, as well as using that red teaming to create guardrails, like Virtue is in fact doing. And we find that very, very useful, because that means now we don't have to reinvent the wheel in every company, but we can either buy solutions. There's also some promising open source solutions for some of these problems out there, rules engines and the like. So we are very bullish on and excited about the sort of ecosystem around third-party tools. Things that is harder to buy or to sort of do outside are things like your policy, right? So if you believe in policy as code, then ultimately you're responsible, you're holding the pen in terms of where that lies, your risk thresholds, any sort of key decisions that you have to make that are unique to your organizations. But this can work well together with the application of third-party safety and security tools from the outside. And the first part of the question, I think I hinted to that earlier, so I'll keep this brief, but you really have to develop a stack-based approach with multiple layers. We're very excited about production-level automated red teaming and safeguards. So instead of the old world where you launched a model or product, you red teamed it, and then you figured out a guardrail, and then you hoped it worked, we're seeing more promising solutions in doing that in real time at the production layer, which requires all the, as you said, like things to work seamlessly behind the scenes, the necessary low latency, etc. So we're very excited about that.
Yeah, so we work primarily with the foundation model companies, so I'll kind of focus on that part of the stack. I think it's kind of the first line of defense, because I know even if you have like great safeguards internally, there have been a couple instances where some engineers at, I think, Samsung, like they were kind of like fed up with their internal safeguards and they just used their personal ChatGPT account and like put in their company source code. So we work a lot with the companies actually doing the training, and I think one observation I had is you need to make sure that the models are kind of learning an objective function that makes sense and isn't too brittle. So a lot of the synthetic data sets used to train models on things like instruction following, people want to basically get scale, so you can just create a data set of a bunch of instructions and then like a verifier, like making sure it followed those instructions, which is great for kind of like getting a large training data set quickly and without much cost. But I think that type of behavior can basically train the model to do the prompt injection reward hacking type behavior, because it's basically seen like hundreds of thousands of examples of like instruction and like verification, like something I should do to get the reward. So when it reads that email and it sees that instruction, it's kind of like thinking like, oh, this is like one of those other hundreds of thousands of examples where I see an instruction and I just always follow it. So I think we're really focused on making sure that the feedback functions that are leading into model training kind of have the human common sense. So instead of just using examples of passing unit tests or like following instructions, you kind of have another human layer that's making sure that, oh, like if it's instruction that doesn't make sense, like the model should push back, or maybe the model should like ask a follow-up question like, hey, like why am I doing this? Like what's the actual purpose of this? And kind of like start a dialogue with the user instead of just like blindly following everything, which can kind of lead to these prompt injections or other like unexpected outcomes. So yeah, I think basically making sure we do the red teaming and then kind of make sure that the way we're training the models isn't too brittle and the feedback function makes sense.
Okay, yeah, thanks. So yes, I have a couple points to add. So first, in terms of this build versus buy question, I think for this, so first of all, right, so the guardrail, I think everyone who deploys agents need to have guardrails. I think it's unimaginable that you just deploy agent solution without any guardrails. I don't think anyone actually can do that. And for building these guardrail solutions, I think, I mean, of course, different companies, they may have their custom needs and so on, but still, in general, like building such guardrail solutions, it needs a lot of expertise. And also, so for example, Virtue, build the guardrail actually has, the best performance and also the lowest latency, and also it gets continuously updated. And for example, when there are these different policy regulations, actually also gets updated to help with compliance for these different policy and regulations and so on. So overall, actually, it really takes a sophisticated team, dedicated efforts to actually build these guardrails, which is difficult actually for other companies who don't focus on this. Then that means they are being distracted. If they try to build, that means they are getting distracted and not building something that's actually unique and core to their mission. And they don't get to amortize the cost and so on as well. So I think for a lot of from Virtuous customers, from what we hear is that actually in general, they would like to get experts in the space to actually help with this. So that's one. And then I think the other part, actually, Artemis also mentioned is to actually really build a security solution for agents. Is actually there's no single like silver bullet. It actually takes a very sophisticated overall systematic approach to actually solve to enhance agent security and really solve the problem in a more holistic fashion. So for example, like in my MOOC, I actually teach this AI building safe and secure agentic AI lecture, where I actually talk about you really need to build defense in depth. So you need guardrails, you also need like safe and secure by design, you need a lot of other security solutions. I call it defense in depth. So in my lecture, I actually talk about over 10 different defense mechanisms that are actually needed. I mean, just as examples, actually the list goes even longer than that. So when you actually build the agent system, you really need to think holistically about this defense in depth approach, this secure agentic overall like framework system approach, and combining these different defense mechanisms to really ensure, improve the security of your agent system.
Thank you for the great insight. Yeah, I think everyone excited about the topic on Guardrails. That's why we add this topic, because everyone, as Don said and as Ms. Andrew said, like no one dare to actually have your chatbot or agent just to go out nakedly without a protection layer. It will extremely, be concerning. That's why we see like from enterprise customers who, as I mentioned, without a mic just now, with hundreds agent and chatbot built, they cannot deploy any, or as well like without the certain like protection, third-party authentication. It's really hard to gain their own customer trust to ensure the adoption of the AI applications such as agentic platforms. So that's quite interesting. And one thing I do want to mention that connecting our topics regarding the red teaming we just discussed and the Guardrail currently as the panelists mentioned, to be honest, like we at Virtual, the Guardrail model and agents are so good in terms of latency, in terms of performance. I think one piece of secret sauce that I do want to share is that indeed we use our own in-house red teaming to empower the Guardrail itself, so that you close the loop and you will actively find the zero-day vulnerabilities in time, and then empower and ensure the Guardrail to be updated so that it can be effective with like our own like award-winning red teaming strategies, as some of you may know, like from National Security Agency, from top machine learning conferences, like the Best Paper Award, so that those red teaming algorithms, I do think, should also be in mind. Either you are building red teaming or Guardrail or AI applications so that it can empower the closed loop end-to-end secure AI systems. So with this being said, I think we're close to the end, but I do have some exciting topics, so that want to finally have everyone to have an opportunity to talk about your vision of next 1 year, 5 year generation of AI applications, agentic systems, multi-agent systems, of course, as we've seen, and also from the security and safety perspective regarding, as you mentioned, company policy, regulations such as EU AI Act and a lot of regulation coming in place. What's that impact to your to the next generation of AI applications, agentic systems, as well as like what you wish to solve, like your wish list for like solving and making sure our AI application and the world will go effectively and widely adopt, and of course make our life better. Yeah.
You want to start?
From the middle.
Sure. Yeah. I'll try to keep it brief since I know we're short on time. Yeah, I'm really excited about helping build AI with human values at the core. So I used to work at Twitter, and I think one of the things we saw there is a lot of the feed algorithms are just optimized for kind of likes and retweets and engagements. And you kind of have the system optimizing for something that isn't aligned with human values, and you kind of get this clickbait type content and this content meant to stoke anger. On the agent side, I think we just want to make sure that the human values are at the core and it doesn't kind of like run away and start optimizing for things we're not interested in, reward hacking, prompt injection, and kind of all these other behaviors that could come from basically creating these reward functions that we don't fully understand.
There's a lot to be very excited about. I'm hoping we can create a world where AI and AI agents enhance human capabilities rather than just replace them, that they are controllable and explainable, and also trustworthy. And I feel like we have a good chance of getting there. For me personally, what I'm very excited about is the ability of AI tools to act as educational co-creators. So in many ways, from art to education to enterprise applications, AI allows people to be co-creators. So for example, nowadays, whenever I'm reading a book, I will have my AI tutor standing right there, or sitting right there, or whatever the verb is, and I will use the book as an incentive and a stimulus to work with the AI tutor to go deeper into a topic. So instead of just passively reading like I would do in the past, now I'm actively, through the catalyzing effect of AI, becoming a co-creator in my educational journey. So there are a million applications like that out there, and I think they're extremely exciting. In terms of where we go with all the safety, security issues, I think there is so much progress has been made, although the risks remain. I think what we're gonna have to look forward to is a point of convergence, both in terms of standards. We're seeing standards emerge, right? Like ISO 42001 and AIUC. We see our enterprise customers in particular being proactive in asking us to show our work and to verify security and safety measures in place, which is actually quite encouraging because it means we're not just passively waiting for regulators to come in and tell us what to do, but the stack, sort of the value chain, is on its own starting to demand standardization. And I'm hoping that we'll see regulatory convergence so that we all have reasonable and meaningful standards that we can abide to instead of the current state where there's both uncertainty and fragmentation.
At the beginning, I mentioned, so from our recent work, it showed that AI agents in cybersecurity has been improving really fast. So I think this, given the dual-use nature of AI technologies, so in particular in this case, the AI technologies can help both the attacker side and the defender side. So it can help a defender to find vulnerabilities and then patches, but also can help attackers to find these vulnerabilities and then attack the systems. So I do see that this actually can significantly change the cybersecurity landscape. So in our recent work, we actually did some detailed analysis on the impact of frontier AI on the landscape of cybersecurity. So exactly for this question, who is AI going to help more, attacker or defenders? Unfortunately, with our analysis, it shows that at least in the near term, AI is going to help attackers more. And with the AI technology, it can significantly reduce the cost of attacks, increase the scale of attacks, and stealthiness of attacks, and so on. So I think we need the society to be more aware of this and be better prepared and to be more resilient. And of course, with all the security, safety issues that we just discussed with Agentic AI, this can make things even worse. And also with all these vibe coding, with the AI generated code, a lot of the code is also vulnerable. So our overall system is actually also moving into a more vulnerable state. So I think that both worries me, and also I think it's really important for us, and also together with the community, to take action. So also recently we launched the efforts called Frontier AI Cybersecurity Observatory, where we actually bring the community together to do continuous monitoring of AI capabilities in cybersecurity to see how, as I mentioned, it's growing fast, it's improving fast, and we need to continuously monitor this and monitor the balance between attacks and defense sides with AI and agentic AI. And I do hope that, as Artemis mentioned, and also as Andrew mentions, that we are, together with our collective efforts, we are heading into the right direction, that we can use frontier AI, use agentic AI to help users and also institutions to build a better world together that's trustworthy, safe, secure, and beneficial to humanity. Thank you.
Yeah. Thank you for the great insight from the panelists. And if we don't have questions, or we're out of time, but happy to discuss offline from the panelists. Thank you.
Thank you.